Okay, so what we had here, we had a rational inequality. So we have two polynomials and less than or equal to a number, or maybe more than or equal to, up to you. So it depends on the question. So we've got critical points which come from the numerator, so x minus 4. So the critical points occur when the numerator equals 0 and the denominator equals 0. So we set that up as x minus 4 equals 0. So we get x equals 4. And we mark that on your diagram here, that's your 4. And from your denominator, x plus 2 equals 0, which means that x equals minus 2. So that's your other critical point, you mark there. Now, be aware here that minus 2 can't be a solution, because if you had x equals minus 2, we'd have minus 6 on 0. And minus 6 on 0 is undefined because you can't divide by 0. So there's no way that that equals 0, is it? So this is actually undefined. So that means that minus 2 can't be part of your answer. So that's why we used an open circle here. Okay, but for 4, if x equals 4, we put 4 in there, we'll get 4 minus 4 on 4 plus 2, less than or equal to 0. So you get 0 on 6, less than or equal to 0. And you can see 0 on 6 is 0, yes? So this is actually true because 0 equals 0, which means that 4 can be part of your answer. So we use a solid dot. All right, and then now we check some other numbers. So when you put minus 5 in your equation, we want to see if that's going to be true or false. So let's try this one here. So minus 5 minus 4, minus 5 plus 2. So you got minus 9 on minus 3, less than or equal to 0. So that's going to give you 3, isn't it? Yeah, 3. Let's just check 3, 4. Yeah, okay, so 3 less than or equal to 0, which is false. Okay, so this area out here, this is going to be false. It doesn't matter where you check, these other numbers will be false as well. So then let's try 0. So if you put 0 in your equation, you'll have 0 minus 4, 0 plus 2, less than or equal to 0. So minus 4 on 2, minus 2 less than or equal to 0, which is true. So we tried 0, this number's true. Every other number will be true. Even the fraction, doesn't matter what you try. Everything between these critical points will be true. So you only need to choose one number between critical points. Don't choose any more because you'll get the same answer. It'll always be true there. So if x equals 5, so 5 minus 4, 5 plus 2, less than or equal to 0. 1 on 7, less than or equal to 0. Well, 1/7 is positive, so this is false, which means that this 5 here, this number is also false. And any number beyond there is going to be false. So now we can see our solution from this number line. So our solution will be from minus 2, but not including minus 2. So x is a member of the set minus 2 to 4, but including 4, like that. So this will be your solution to this problem. So to make this statement true, the x values must be between minus 2 and 4. Then this will be a true inequality. Outside of that, it would be false. All right, I guess if you're writing that, you want to copy that down. Now, I'll start you on this one and maybe you can finish it. Now, the problem here is that you've got 1 on this side and I want to have 0 here. So the good idea here would bring the 1 to the other side. So 5 on x minus 4, minus 1 greater than or equal to 0. Okay. Now we want to make this into one fraction. So we want to get a common denominator, x minus 4. So I will multiply top and bottom by x minus 4. Let's move that for a minute. So we'll have x minus 4, x minus 4. And x minus 4 and x minus 4 is 1, so we can do that. Like that. So I just put that 0 back. So now we make this into one fraction. So we'll have 5 minus x minus 4, all on the common denominator, which is x minus 4. Like that. And now we make this into our fraction that we want our rational expression. So 5 minus x plus 4 on x minus 4 greater than or equal to 0. So I'm going to let you work on this for 5 minutes and I'll finish it. If you get your final answer, you can type into the chat. Okay, you don't have to do it. You don't have to put it in, but I recommend try and then see if you can do it. So your expression would be 5 plus 4, 9 minus x on x minus 4. We don't need to swap anything around there, leave that. So what's your critical point from the numerator and your critical point from the denominator? Okay, I'll let you try that for yourself. And if you get an answer, just put it, it's going to look like this. Your answer with a curved bracket here and a square bracket. So in your chat, you can put your answer in like that and I'll understand what you mean. So I'll let you do that for a little while, and you need your number line too. So get your critical point, put on your number line with 0 there, for example, and then check some points around the critical points, all right? Okay, you try that for a minute. I'll let you do that. And if you get an answer, put it in the chat. Right or wrong, just stick it in. Oh, an answer already. Is that actually with working, or is that with the item pool or with the Panavit? All right, so, right, but you need your brackets. Can you put your brackets in? What do the brackets look like? The numbers are correct though. So I put your brackets so I know what number you're going to include and not include. But this method is the same that you learned with polynomials already, remember? We use the test, this is the test point method. One of them should be a square bracket, Nicole. You got 4, 9, but one of those is a square bracket. Which one? Yeah, so this is the method we actually learned when we did polynomials. It's called the test point method. So I can write that here. There are other methods. But they will lead to the same answer. I think this is actually the quickest way. There are other methods to do these. Graphing is one of them, but I don't recommend graphing because the graph is quite difficult to draw and to draw it accurately and solve it. So another answer. Who else? Yeah, Nicole. So that would be, yeah, that's correct. That's right. So Nicole's got the right answer. Who else? Let's take a look. You got 9 minus x. So let's write 9 minus x equals 0. So that means x equals 9. So this is your first critical point. So you put 9 here. And don't worry if we include that yet. We'll look at that. And then x minus 4 equals 0. So the other critical point is when x equals 4. This is when the value changes from true to false around these numbers here. That's why we call them critical. So 4, I might actually move the 9 a bit. Let's go up a little. Let's go up a little bit. So you've got 0 here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is here. Now, you see if x is 4, you'll get a denominator which is 0, which means 4 can't be part of your answer. So we do an open circle to show it's not included in the solution. But 9 can be included because 9 minus 9 is 0, and this says equals here. You see that equals, which means that 9 can be part of your answer because we have an equals 0 in the inequality here. If that was greater than 0, then 9 would not be included either. So let's include 9 because that can be part of your answer. Let's check some points. So if you check 0, so you take 0 and put it into your inequality. So you've got 9 minus 0 on 0 minus 4. Is it greater than or equal to 0? Is this true? 9 minus 4 greater than or equal to 0. That's going to be false. So this is false. And it's going to be false everywhere up until that critical point. You can check some if you want. So that's false. Now we try a number between 4 and 9. 4, 5. Let's try 6. So we put 6 in. 9 minus 6, 6 minus 4. Is that greater than or equal to 0? 3 on 2, yes. So this is true, which means every other number will be true here, assuming you have the correct critical point. And we can try here 10. So let's see if 10 is true. So 9 minus 10, 10 minus 4. Is that greater than or equal to 0? Minus 1 on 6, no. That's less than 0. So this is false here. And so on till infinity. And the same in that direction, that will always be false. So our final solution then would be numbers between 4 and 9, but not including 4. So X is a member of the set from 4, curly bracket, a curved bracket, up until 9 with a square bracket. So that's your answer there. So any number between 4 and 9, including 9, will make this statement true. Okay. Right, let's look at the next one. What do we got? Right, why don't you try this one yourself? Okay, I'm not going to do any work. I want to see if you can do it. So move the 2 over first and make a fraction. And then, because I want 0 here, okay? I want it looking like that. And then you do the same method. So what I'll do, I'll move it down. So if you don't have the paper, can you write that question down? And then I'll go back to this previous one. And when you put your answer in, you can write it in the chat. Okay, so put it in the chat, what you think you get. And let's see. So I'll move down to the example, the previous question, so you can follow that one. So it's 3 on x plus 4 greater than 2. So write that down, some of you who need to write that. And then I'll leave this one here so you can follow that method. All right, try that one. I'll give you 5 minutes. And see what that's like. You can check your answer with the Photomath or the Desmos website. Okay, try that. I'll be back in a second. Okay, we got an answer. -5 on 2, -4. That's okay, but they have to be in a swapped around, but we'll see that in a minute. We put -4, and you need the bracket too. That's part of it. You need the brackets around those to show whether they're included or not. So let's take a look. Okay, so we want to get the 2 to the other side. So we'll do that first. So we got 3 on x plus 4, -2 greater than 0. So just stick the 2 on this side. So now we make this a common denominator. So we'll have 3 x plus 4 -2 x plus 4 on x plus 4 greater than 0. Like that. So now we'll join this fraction. So you'll have 3 minus 2 x plus 4 all on x plus 4 greater than 0. And now we'll just expand the bracket there. So we'll have 3 minus 2x minus 8 on x plus 4 greater than 0. So 3 minus 8, that's -5, minus 2x on x plus 4 greater than 0. Let's just keep track of my work. Right, so your critical point from the numerator will be -5 minus 2x equals 0. So 2x equals -5. So x is -5 on 2. Just rearrange that. So -2.5, that's your first critical point. And the denominator will be x plus 4 equals 0. So x equals -4. All right, so we'll make our graph, number line. So we've got 0 here. This is -2.5, isn't it? So we got 1, 2, 3, 4, 5, 6. So -1, -2, -3, -4, -5, -6. So we're going to have minus 4, which can't be included because you'll end up with 0 denominator. So that's an open circle. And minus 2.5 cannot be part of the answer because there's no equal sign here. You see that? So in this case, minus 2.5, which is here, has to be an open circle as well. Because if you put minus 2.5 here, you'll get 0, and 0 is not greater than 0. You would have to have an equal sign here to have the solid dot. All right, so just be aware of that. So we're going to check some numbers. So we'll check minus 3, because that's in between the two critical points. So x equals minus 3. So you get minus 5 minus 2 times minus 3 on minus 3 plus 4. Is that greater than 0? Minus 5 plus 6 on 1, greater than 0. 6 minus 5, 1 on 1, which is 1, which is greater than 0, true. So in here, this is true. I think if you check the other side, it will be false. But you do need to check the other side. So I'm going to skip that for now. But you're going to find that these other sides here are false by checking. You should check every part. So your solution then is in here. By checking, these will be false out here, this side and that side. But not every question is like that. More complicated questions, sometimes this is true. And then this part is also true. It just doesn't include the middle number. Okay, so be aware of that. So you should check each part. Don't skip steps like I'm doing. So your solution then will be x is a member of minus 4 until minus 2.5. Put the smaller number first, okay, that we do when we do this notation. So x is a member of that. So I'll write that in there like that. So that's your answer there. So between minus 4 and minus 2.5 for that one. Look at this one. Because it's a quadratic, you don't have to panic about it. You do it exactly the same way. So you do this with me if you've got your tablet there. So your critical point from the numerator, do that, and then critical point from the denominator. So critical points are where the numerator and denominator equals 0. So we'd have x squared minus 7 equals 0, and 2 minus x squared equals 0. So we need to solve these. So x squared is 7. So x could be plus or minus root 7. Don't forget, when you square root, you can have two solutions to that. And this one, x squared equals 2. So x would be plus or minus root 2. So now you've got 4 critical points because of the shape of this graph, because it's got quadratics in it, that's why. So I might go to the Desmos and show you why in a minute, but we don't have a lot of time. So we've got 0 here. We've got root 2. We've got root 7. We've got minus root 2, minus root 7, something like that. So can you do that? And then, your solution has different parts. So now you've got many things to check here. So what numbers could you use? What's the difference between, sorry, the curved bracket? Who's that, Nicole? So if you're including a number, we'll use the square bracket. So this is like this here. So when the number's included, so if you had 2, 4, your solution would include 2, but not include 4. So we use an open circle, which is an open bracket like that. So that means 2 is okay, but not 4. And any number between 2 and 4, but not 4. That's what that means. Yeah, square bracket is equate to the solid dot. Is that okay? All right. So you can, I didn't see that message. I was just got in this. So now you choose some numbers along here. So 0 is, we can use 0. So I'll give you some to use. So you check with 0. What's between √2 and √7? What about 3? I think 3 is between √2 and √7. What did I use? I used 2. Let's use the ones that I got in my answer key. So 2 and 3 is okay because √9 is 3. So try 3 and then try between 0 and √2. So this will be 1. So try 1 here. Try -1 here. Try 2 here. And try 3 here. So you should try all of those numbers back into this equation here and see if it's true or false. Okay, you do that for a minute if you haven't done it yet. So check each number to see if it's true or false, the red numbers. And then from that, you should be able to get your solution. We may do a few lessons during the year when we're back at school. Hopefully we'll be back maybe middle November to late November, but they're not sure yet. If we get back to school, we can do some review. And we may do a review online as well if we're in the Zoom class, because this stuff's not really finished yet. Okay, how's that going? So you're going to get a solution which has got various parts. Now, I'll just show you what happened here. Like 3, if you sub 3 back into here, so we won't do them all, but we've got x equals 3. So you're going to get 9 minus 7, 2 minus 9, less than or equal to 0. 9 minus 7 is 2, minus 7. So this is going to be true out here. So between minus √7 and minus √2, we use 2, but this actually is false. So I'll tell you now, that's going to be false. If you try -1, that would be true. If you try 1, it's also true. If you try 2, it's false. And if you try 3, that's going to be true. So you can see you've got true in different places. So let's look how to write that. Okay, so let's try. So we've got x. X is a member of. Okay, so if you go to -infinity, this will always be true. There's no more critical points out here. So you're going to go from -infinity to minus √7. That's this bit here, up to there. Okay, that's this bit. Now, between minus √7 and minus √2, that's false. But then we got between minus √2 and 0, which is true. So we'll go union or, remember union is or. So then we're going to go for minus √3. Then we'll go up to 0, but we don't include 0 here. Oh, 0 can be included. Sorry, 0 is true. I missed that. So actually go for minus root 2, like root 3. There. Let's fix that. It looks like root 3, doesn't it? So minus root 2 will go up to, and root 7 can be included. I should have used a square bracket there too. So that's square bracket, okay? Square bracket. And also these can be included because we've got an equal sign in the question. So square bracket will go up to root 2, square bracket, or square bracket from root 7 to infinity. So hopefully I fixed that up, okay? But remember, a curved bracket for infinity because we don't stop at infinity anywhere. Is that okay? So that's basically what you should have gotten. It's kind of difficult, isn't it? Because we got multiple parts. So we've got this section in here, and 0 is included as well. 0 is okay. And then we've got, in yellow, then we've got this bit here, which is true. And that bit here is blue. And the remaining parts are false. So if we actually type that into Desmos, let me go to the internet. Hold on. Let's see if we can see what that looks like. Okay, I'm gonna type it in here. So we got x squared minus 7. I'll show you in a minute. I'll share it in a minute. On 2 minus x squared. Right, I'm just going to leave it like that. And okay, so let's I'm going to share this new page here. Share. Okay, so now you can see the graph, the actual graph. Let's make it a bit smaller. So it looks like that. It's kind of weird because when you've got a quadratic involved, you get some strange shaped graphs like this. And where is this graph less than or equal to 0? Okay, less than or equal to 0. So remember, let's write on the picture. The question was, so x squared minus 7 on 2 minus x squared, less than or equal to 0. So I want to know, where is this below the x-axis here? Where is it this value negative? So we're asking, where is this value negative? And look at your axis. This is your x-axis. So we're going from this point here, there, and here. So obviously from here to infinity, if we zoom that, you're going to see that. I can't zoom now, the text will disappear. But the graph here is below the axis, isn't it? And that number there is minus root 7. This point here is root 7. And so here the graph is below the axis too. It's less than 0, right? So we're following this here. But this is also less than 0. And that there is between, you can't see it. I'm going to make this disappear in a minute. I'm going to make it disappear now because I want to zoom. So go down. I need to use my mouse better for this. Hold on. It's hard using the pen. So you see this here. This is between your minus root 2 and root 2. So if we zoom, you can't actually tell. So minus root 2 is going to be near this x value here. See that minus 1.327? That will actually be close to minus root 2 if you check. So those are asymptotes. Look at that graph. Look at that. I'll zoom out. So your graph looks like that. So we're here, we're below the axis. from the root 7, minus root 7 and plus root 7, and also here. So I'm going to write in asymptotes. X equals root 2, so 2 to the half power. There, you see that blue line? And the other one is x equals minus root 2. So x equals minus 2 to the half. This is why you don't use graphs to solve these problems. You do it like I just showed you with, 0.5. Okay. So these are asymptotes. Remember we talked about asymptotes previously. So we can ignore what's going on up here, but look at this down here. You see how the red line, your graph gets close to the asymptote. And this is here, this is root 2. And this on here is minus root 2. So minus 1.414, that's nearly minus root 2. But you can see when you zoom out, it looks like it's touching, doesn't it? So let me go all the way down. It looks like you can't see the red line, but let's have a look what happens here. I'm going to zoom in now. Now look at that. So now they're separated. But if you look at the top here, that's 1.4, that's 1.45. It's almost the same number. You just can't see it when you zoom out like that. But yeah, like I said, we wouldn't use graphs to solve these. What we could have done is done that as less than or equal to 0. There. So now it gives the solution. The colored bit is the solution. Let me go back. So if you want to do this in Desmos, you can type the question like I just did there on the, oh, I'm going up, hold on. Here we go. Right, so now it doesn't show the graph, does it? It's showing the solution to that problem on the left side here. So if you go in Desmos, you type your question, the solution is shown in pink here, or is that brown? So you might find this here, this point is going to be your root 2, where my arrow is, let's mark that. So you can use this program to solve them. That's just what I'm saying. So this here is root 7. And that there is your root 2. This here is minus root 7. And that there is minus root 2. So now you can see the solution is this way and in this direction to the left, and also between minus root 2 and root 2. So you can use this program to do that, but it's a bit difficult to use, as you can see, but you'll get used to it later. So let me unshare that and I'll go back to the where we were. So we got about another 6 minutes. So if you looked at this one here, this will be a bit harder. Okay. What do you think you need to do here then? E. Anyone have an idea? What should you do with this question first before you do anything?
Factorize.
Yeah, factorize it. So what would be the top factors then? What would be the numerator? So x, isn't that x? Now I'll go back to my pen, not the mouse. So x plus 1. No, it's better. So x plus 1, x plus 1, right? So if you can factorize any problem, you should always do that first. And this would be x minus 5x plus 3, isn't it? So x, sorry, was it, yeah, x minus 5, x plus 3, yeah. Okay, so now you've got two quadratics, nothing cancels out. So you're going to get x plus 1, x plus 1. So your critical points for the numerator, x plus 1 equals 0. So x is minus 1. There's only one critical point from the numerator. So for your denominator, x minus 5, x plus 3 equals 0. So x would be 5 and minus 3. So these are your three critical points. So we make a number line. So can you draw that? You should work with me now. So let's put a 0 in somewhere, and then we got 1, 2, 3, 4. And we're going to go to 5 and 6 actually. So 5 and 6. So now we go in the negative direction because we've got -1 and -3 there. So -1, -2, -3, -4. You don't need to go any further than that. Now look at your question. It says equals 0, which means in your numerator, we can have x equals 1 as a solution. If you put 1 in here, you're going to get 0 for this on the left here. So we can include -1 in the answer because of this equal sign here. So we'll include -1 to do an open solid circle. But look at the 5 and 3. No, 5 and -3. If it equals 5, you're going to get 0 in the denominator. And if it equals -3, you'll also get 0. And you can't have 0 denominators. So that means that 5 and -3 are not included in your answer. So do an open circle and an open circle there. Right, we only have a few minutes. Can you do that and check which is true or false? And put them back into your equation here. So try -4. So we try that one. Then we can try -2. Then we can try 0 because that's an easy one. And then we can try 6. All right, so just find your critical point and choose a value in between the critical points and test them. So this is test point method. And we're looking for whether they're true or false. That's all. And that will give you your solution. But as you saw earlier, if you do it by graphing, you're going to die because you can't do this by hand, the graphing method. So keep this in your mind because I may give you some of these later. Okay. So think about your solution. So what about -4 or -5? You're going to find this area out here is going to be, this is going to be true out here. So I'll help you out. If you try -2, this is going to be false. And if you try 0, this is going to be false in here as well. This area in here. So I should write false, I guess. So put false here. And it's false everywhere. And on the other side, this will be true. Like that. But notice you got a number in the middle here. That's called a singleton. So it's actually just a number by itself. Every other number is going to be wrong. It will be false around it. So we'll go down. So let's write the solution out. So x is a member of. So we're going to go from -infinity up until -3, but not including this number. Union. Now this is all false except this number here. This is true. And if you graph it, you'll see why. But this number is true, but everything else around it is false. So we actually put that into a different bracket like this. It's only one element. You see that bracket? you could use a square bracket, but when I double checked on the internet and I did a bit of research, they write that as in the set form like that. Union from 5 to infinity, like that. So when you have a single element that's in your set, you can write it in the set with a curly bracket like that, that one. So it looks a little bit different than the other ones. But if you use a square bracket, that would be all right as well. You can use a square bracket. Okay, so that would be your solution there for that one. So I'll post this on the internet later. I may not bother to edit it, so it's going to have a bit of crap in it. So you'll have to go through the video and find the stuff you want to look at. Okay, so I think we'll stop there because it's 12:20. I don't think I see you again for a while. But if you want to do a bit more in this workbook, go ahead and do some on the holiday if you want, and just try some more. There's another one you can try here. That one's interesting. And then there was word problems. So we basically covered everything in this book over a few days. But if, like I said, if you want to go back, just try some more yourself. But when we come back to school, we'll be doing coordinate geometry. And I might include a bit in the quadratics on that we missed in the semester one that we should cover, a bit about graphing and stuff. Okay, so I think I'll see you soon. I think I may make a new classroom for semester 2. So all my grades are going to be separate. So I'll set up a new classroom and I'll invite you, I'll give you the code and you join the new classroom, because otherwise it's got all the other thing from semester 1. So we might set up a new classroom in semester 2. All right. Okay, I'll talk to you later then. All right. Have a good holiday and see you later. All right. Bye-bye.
Bye bye, Doctor.
Bye, teacher.
Right. See ya.